Hello everyone, welcome back to my YouTube channel. I am Pratibha Rani and today we'll discuss about the section C of computer forensic science. Okay, so before that, just an announcement for you guys that you can join my Pratibha's forensic notebook for the latest notifications regarding the lectures, and also you can join my WhatsApp community that is with the same name, Pratibha's forensic notebook. You can scan this QR code and you can join this community directly, and you will get the notes in this community only. Okay. So guys, in the section C, we'll cover the topics from first responding role to till imaging and hashing digital evidences. Okay, because analysis and recovery of deleted and other files is a very vast topic. So, and it is also very different process for every digital evidence. For example, mobile phone, it is a very different process, and for hard disk, it is a different process, like with different kind of tools. Okay, so we'll discuss it later on when we will study the analysis portion. Okay, so let's start with our lecture, guys. So first one is the role of first responder. So guys, who is first responder? Any police officer who arrive at a crime scene first and are responsible for securing the area and providing emergency aids and preserving the evidences. Okay. So in digital forensic also, the first responder play a very important role to preserve and to secure the digital evidences at a crime scene, and also like maintain the integrity of evidences. So not to compromise the evidential value. Okay, the first responder officer basically first of all secure the crime scene, and after that preserve the digital evidences such as a computer, mobile phone, external drives and cloud accounts, etc., and also have to maintain to maintain the integrity of the evidences. Then about toolkit, they should carry one toolkit with themselves, which includes the hardware and software tools for acquiring imaging and analyzing digital evidences. Okay, so in that particular toolkit, they should have write blocking devices. And what are write blockers, guys? Write blocker are the tools which are used to securing the individual write access to the digital evidences, therefore allowing read-only access to the storage devices. Means you can only read the files or data in any particular storage media. You are not able to make any changes through these write blocking devices. Okay, so you should use the write blocking devices whenever you are visiting the crime scene. As in our previous video, we have studied the principle of forensic science. So in the same way, in computer forensic also, first responder basically follow these 5 rules or 5 principles of computer forensic science. So let's discuss one by one. So the first one is never mishandle the evidence. Means you never make any changes to the any particular storage media or any digital evidences at a crime scene, and also use the best imaging tools at a crime scene. Okay. Then second say never work on original evidence. Means to maintain the integrity and authenticity of the evidences. Okay. Then third one say never trust the subject's operating system. Okay, because means criminals can change normal computer commands to do harmful things, so which can result to ruin the data. Okay, so we first of all we have to see like the booting process of any computer system, and after that get into the system and do the imaging and see through the write blocking devices. Okay. Then fourth one is document everything. Means to maintain the chain of custody, like a list of the dates and time of the evidences handled and who is handling the evidence. Everything should be written in the chain of custody form. Okay. Then fifth one is the result should be repeatable and verifiable by a third party. Then let's see the disk imaging tool requirements. So what kind of a disk imaging tool you need? So you need the tool which can make the bitstream copy or image of any particular hard disk or any particular storage media. Okay. Then it should maintain the integrity of the evidences, like to preserve, it should preserve the original state of any particular storage media. Okay. Then third one is the tool must possess the capability to confirm the integrity of a disk imaging file. Means it should have the some hash value of any particular file. Okay. Then fourth one is the tool should have the capability to record the input and output errors. Okay, so if any error comes in doing the imaging file, so it should show us that the error came in this sector. So then fifth one is the tool is expected to come with comprehensive documentation for user reference. Means it should create the log. Okay. Then guys, let's see about the type of digital evidences. So before proceeding for types, we should know what is digital evidence. Any information or data which is stored, received or transmitted by any electronic devices, okay, is known as digital evidence. Okay, for example, emails, text messages, CCTV footage, videos, and any kind of records such as logs, system files, cell phone data, images, photos, screenshots. Okay, so now let's see the type of digital evidences. So digital evidences is divided into three parts: static digital evidence, live digital evidence, and remote digital evidences. Okay, so let's understand. So first one is static digital evidence, means when you are collecting any particular data from an powered off system. Okay, for example, hard drive images acquired after shutting down the computer systems. Okay, then second one is live digital evidence. Live digital evidence means when you are taking the data while system is running. Okay, so for example, memory dumps, like when a system is running and you are taking the memory record. Okay, then third one is remote digital evidence, means when you are getting data from a remote location or over a network. So when a internet is included, when a internet is used to take the data. Okay, for example, logs from a web server, or such as email headers and content transmitted over the internet. Cloud storage files are also like type of remote digital evidence. Okay, so basically when you are using the internet to uh, take the data. Okay, so based on volatility, the digital evidences are divided into two parts: volatile digital evidence, non-volatile digital evidence. Volatile digital evidence means when the data is temporary and lost when our device is powered off. So if you shut down your computer system, you will lose the memory. So for example, RAM. So, and then here is like acquisition tools are written for volatile digital evidence, such as FTK major volatility framework, RAM capturer, Belka soft live RAM capturer. Okay, and analysis tools, volatility framework, and Ricali X base forensics. Okay, then non-volatile digital evidence means when the data is stored on a device remains intact even when you shut down your system. Okay, for example, hard disk. Okay, so for hard disk you can have the acquisition tools. You can use the acquisition tools such as incase, write blockers, and analysis tool will be FTK, Celebrate, physical analyzer, etc. Okay, so till here we have covered the type of digital evidences. Then guys, these are some important acts or sections you can study, like section 22A, 45A, and 65B. These are important sections regarding to computer forensic science, so you can study this by your own. Now let's see the simple steps of search and seizure of digital evidences. First of all, authorization means whenever any police officer go at a particular crime scene, and they should have some legal authorization such as search warrants to seize any particular digital evidence. Okay, then the second one is documentation, means document the condition of any particular storage media or digital evidences, such as their locations and relevant information like name, serial numbers, and operating systems. Everything should be documented at a crime scene. Okay, then third one is seizure. So in seizure use, so you can use the Faraday bags to store the digital evidences such as mobile phones, and also you have to put the tags on any, so you have to put the tags on every item to maintain the chain of custody. Okay, then fourth one is transportation, means transport the seized devices to any secure location for analysis, and also protect the evidences from any physical damage or unauthorized access. Okay, so these are just simple steps of search and seizure of digital evidences. Then let's see the concepts of imaging and hashing. So guys, you have to study the imaging and cloning difference first of all. Okay, just google the difference between imaging and cloning. Cloning is one by one copy of any particular storage media, and imaging is just the process of creating an exact copy of computer storage media, which also include the hidden or deleted files, means it will also include the unused disk space or unallocated disk space. Okay, in imaging. So for doing imaging we can use different tools such as FTK imager. In case also we can acquire Falcon, which is a disk imaging tool, Tableau, which is also a disk imaging tool. So we can use different tools for imaging purpose. Okay, so guys, now let's see the hashing. So what is hashing? Hashing is the process of creating any particular unique code. Okay, so in this process mathematical algorithm is used to create unique code for any particular file. For example, At the heart of hashing algorithm are mathematical functions that operate on two fixed size block of data to create hash code. For example, here is your data in one data block. Okay, so after that we will apply some mathematical formula here, some mathematical calculation formula here. Then it will give you the specific hash code. Okay, which is a different for every file. Okay, so guys, you can study this ripple effect or here. uh, so there are a different type of hash values, okay, depending upon the bit size. Okay, so crc2 means cyclic redundancy check 32, and it was discovered in 1961, and it is having a bit size of 32 bits. Okay, then md5 means message digest algorithm 5, and it was discovered by Ronald in 1991, and it will have 128 bits. Okay, then third one is ripe md, means race integrity primitives evaluation message digest, and it's having a bit value of 128, 160, 256, and 320 bits. Okay, and it is used in Bitcoin and another cryptocurrencies. Okay, so guys, just go through this table. Okay, this is a very simple table I made, so so that you can remember the bits used in every hash type and also the full forms, because these simple questions can be asked in fact exam. Okay, then second one is SHA-1. SHA is secure hash algorithm, which is developed by NIST and NCA in 1995, and it's having a bit value of 160 bits. Okay, then second one is SHA-2, secure hash algorithm 2. It is also discovered by or developed by NIST in 2001, and it's having a bit value of 224, 256, 384, and 512 bits. Okay, then murmur hash, it is developed by Austin in 2008, and it contains the 32, 64, and 128 bits. Okay, then there are three more, so guys, just read these also. So till here we have completed our section C of computer forensic science, and if you have any query, you can contact me on my LinkedIn profile also, or on my WhatsApp community also. I will provide you the notes of this particular lecture also in my WhatsApp community, so please guys join the WhatsApp community and study well. Okay, bye bye, take care.